All right, so let's begin with the first question, which is find the area of the indicated region under the standard normal curve. Remember, guys, when he says a standard normal curve, that means the mean is 0 and the standard deviation is 1. How do I find this area? This is an area to the right of negative 1.30. It looks like it's more than 50%, as you can see, guys. So actually, we need this. We need, area is a probability. We need the probability of z greater than negative 1.30. Why did I put greater? Because it's going to the right. And why did I put z? Once you see a 0 in the center, it's a z distribution. Do you still, guys, remember what the formula is? It's normal CDF. We need a lower bound. Let me remind you of this. We need the upper bound. We need the standard deviation, the mean, and the standard deviation. Lower bound is, what's a lower bound here? We're starting at negative 1.3, so it's a negative 1.3. Upper bound, the sky is the limit. Make it as large as you want. Put a million here if you want. Mean is always 0 and standard deviation 1. And let me show you how to do this on the calculator. Here you go. So let me clear here. Okay, so you go to second, and then variables, which is distribution. I need the normal distribution. This is the only function that you use, guys. You don't use normal PDF at all. It's normal CDF. Okay, it's asking me for my lower bound. My lower bound is negative 1.3. My upper bound is a million, 0, 1, and then paste. Okay, so it is 0.9032 to 4 decimal places. Any questions about the first one? You could also use the table to find this value. There are table of values. You could use the table and do it by hand, but if you know how to use this formula, normal CDF, that will substitute for the use of the table. So I would use the formula if I can, but the table is also an option. But the table is going to give you the area to the left of negative 1.30. Then you have to do 1 minus in order to find this. Whereas with the calculator, you don't have to worry about it. It's just one shot. Number 2, assume that the salaries of elementary school teachers in the United States are normally distributed with the mean of 32,000 and a standard deviation of 3,000. If one teacher is selected at random, what's the probability that he makes less than 28,000? So guys, look, it's like this. Probability of X less than 28,000. Now, if you ask me why I didn't put Z here, he gives me a mean and standard deviation. They're not 0, 1, so it is X. And again, it's normal CDF. Can one of you tell me what would be the lower bound, the upper bound for this? You can send me a chat message. So what would be the lower bound here? Less than 28,000. So from 28,000 and down. When it is a less, guys, your lower bound should be always a very large negative numbers. I tell my students to put a million, negative a million, negative a trillion, whatever. Just put as many zeros as you want. Up to 28,000. And then the mean is 32,000. And the standard deviation is 3,000. All right, so let me show you how to do this on the calculator. So this is still the normal distribution chapter, guys. We're working on this one. All right, so on second and distribute normal CDF. Now, some students who have an older calculator, it's gonna say normal CDF and open parentheses. So you put those 4 values between parentheses, but make sure to put a comma in between. So my lower is a negative a million. Put as many zeros as you want. So negative a million. Upper is 28,000. Mean is 32,000. And the standard deviation is 3,000. Here you go. That's the answer. 0.0. I'll do 4 decimal places. 1, 2. All right. So that takes care of question 2. Question 3. Assume that the heights of women are normally distributed with a mean of 63.6 inches and a standard deviation of 2.5 inches. The cheerleaders for a local professional basketball team must be between 65.5 and 68 inches. If a woman is randomly selected, what's the probability that her height is between 65.5 and 68? That should be an easy question, guys, because he gives you the lower bound and the upper bound. 68, 65.5 equals normal CDF. Okay, what I'm gonna do now, guys, I'm gonna pause. Normal CDF, 65.5, 68 is the upper bound. Mean is 63.6. Be very careful, check your entries before you press enter, just in case. And now here's how you do it, guys. Second, variables, it's number 2, not number 1. We don't use number 1. 65.5, 68, 63.6, and then 2.5. I got 0.1844. If the computer asks you while taking the test to change this to a percent, or it says what percent is between 65.5, 68, change it to a percent. So multiply by 100 will be 18.44%. You guys have to be very careful in providing the answer as you are asked. If you're asked to round to 3 decimal places, you must round to 3 decimal places. Otherwise, the system will mark it wrong. Number 4. Assume that blood pressure readings are normally distributed with the mean of 111 and standard deviation is 7. A researcher wishes to select the people for a study but wants to exclude the top and the bottom 10%. What would be the upper and lower readings to qualify people to participate in the study? So we're saying the one whose blood pressure is very low are going to be excluded, and the one whose blood pressure is very high we're going to be excluded. The bottom 10% and the top 10%. Now he's not asking you for a probability, guys. He's giving you the probability and he wants you to work your way back and find X. So let me show you a sketch on how to do this. This is where everybody is. We want to exclude bottom 10% and we want to exclude the top 10%. And we want to take people who are between this point and that point. So you guys, you have to find the values here. You have to find this X value and you have to find that X value. One is going to be low and the other one is going to be high. Here's how you find him. He gave me the probability. He gave me 10% to the right and 10% to the left. So I need to use a function that will figure out X for me, which is the inverse norm. So for X1, it's going to be inverse norm and tell you what are the requirements of this function. 3 requirements. If I want to find X1, I need the area to the left of X1. And what is the area to the left of X1, guys? It's 10%, so just put 0.1. And you need the mean, which is 111, and you need the standard deviation, which is 7. So that takes care of X1. Now for X2, watch. It's inverse norm. I need the area to the left of X2. Can a student tell me what's the area to the left of X2? 90, exactly, Ryan. Because there's a 10% to the right, so 90% on the left, exactly. 0 0.9, 111, and 7. And if you guys, I think a student did the math for the first one, which is 102. And what would be for the other one? Probably 120. So let me show you the function, guys. It's right here. Second variable, second variables, inverse norm, number 3. So you will need this one, area is 0.90. Mean is not 0 here, 111. And standard deviation is 7, paste. You see, for students who have the older operating system, you just have to do inverse norm, enter 0.9, comma 111, comma 7. 119.97. So I was right, 20, 120. All right, number 5. Okay, number 5 is for my students taking the course on campus, section 5.4. And my students in section 98, 99 is section 8.1. Assume that the salaries of elementary teacher schools in the United States are normally distributed with a mean of 32,000 and a standard deviation of 3,000. If 100 teachers selected at random, so it's not about one person anymore, it's 100 of them. What's the probability that they have a mean salary greater than 32,500? So guys, it's not the probability of X here, it's the probability of X bar. He's asking about the sample mean greater than 32,500. Again, it is normal CDF. I need a lower bound. My lower bound will be starting, when it is a greater than, guys, your lower bound is this number right here, 32,500. Your upper bound, the sky is a limit. So I'm just gonna put 0 here. Mean, 32,000. And now we're gonna pause. If you put 3,000, guys, you're gonna lose the credit on this question. Because when you work with samples, the standard deviation, the original standard deviation does not remain the same, it changes. There is a new standard deviation, which is a lot smaller, which is the previous standard deviation divided by square root of n. So this is a 3,000 divided by square root of 100. Now your answer should be correct. So every time the question is about a sample, probability of a sample, the only difference between what we did earlier and this one is instead of sigma, you have to use sigma of X bar, which is 3,000 divided by square root of n. And let's see what the answer is. Second variables, normal CDF, same thing, 32,500. Upper is 1,000,000. Put as many zeros as you want. It doesn't change anything. 32,000. And sigma, 3,000 divided by 10, which is 300. I got 0.0478. All right. So that's number 5. Number 6. The mean annual income for adult women in one city is 28,520. And the standard deviation of the income is 6,000. The distribution of income is skewed to the right. Find the mean and the standard error of the mean for the sampling distribution when using random samples of size 78. Again, we're talking about samples, guys. For samples, the mean of X bar is the same as the mean of the original population. When you work with samples and we collect so many samples and we find their mean, it turns out to be the same as original population mean, which is 28,520. So that answers the first part. For sigma, the standard deviation of the samples, I put X bar to say samples. It is the same as original standard deviation divided by square root of n. So it will be 6,000 divided by square root of 78. And I'll let you guys do the math here. That's what he wants. This is called the standard error of the mean, or this is called the standard deviation of the sample mean. So if you see this question, guys, here's how you answer it. If it gives you a sample size, you must use it somewhere. Well, that's the formula. Number 7. So we're done reviewing normal probability. It's done. Now I'm going, guys, to chapter 6 for my on-campus class and chapter 9 for my sections 98 and 99. A nurse at a local hospital is interested in estimating the birth weight of infants. How large a sample must she select if she desires to be 99% confident that the true mean is within 2 ounces of the sample mean? The standard deviation of the birth weights is known to be 7 ounces. Okay, here is the formula, guys. N equals. Formulas will be provided to you, and you can download the formula sheet and have it handy if you like. That's the formula that we're going to be using. ZC times sigma divided by E. Okay, let's see if we have what we have. Do we have sigma? Yes, we have sigma. He says population standard deviation is 7. So let me write this down. Do we have E? Yes. He said he wants to be 99% confident that the true mean is within. The word within, guys, should give you a clue that this is the margin of error, 2 ounces. So we have E, we have sigma. Oh, I still need Z. Z is the critical value based on the confidence level, 99%. Let me show you how to find this one, but I did ask students to try even to memorize those 3 critical values, the 99, 95, and 90. For 99 is 2.575. For 95 is 1.96. And guys, for 90 is 1.645. But let me show you how you would find this on the calculator. Okay, let's do this together. Let's say he gives you 98% confidence level. How would you find, ZC? So I'm going to show you how to demonstrate that on the calculator. Subtract 99% from 100%. So you get 1%. Divide the 1% by 2 because the confidence interval has 2 tails on the right and the left. If you divide 1% by 2, what do you get? 0.005. And let me show you how to find those values. You go to second, distribute, inverse norm, and enter 0.005, which is 0.5%, and leave this 0.1 because we're working with Z here. Paste. You see, guys, you got the 2.575 that I told you about number, but I got one negative and the other one is positive. We just use the positive one. It doesn't matter because we are squaring here. So whether you use a positive or negative, it doesn't matter. So your answer will be 2.576 or 5. You can use the 5 times 7 divided by 2 squared. Let me just do this math. All right, so let's do 2.576 times 7 divided by 2 and then square. I got 81.288, guys. So what would be the sample size? The sample size must be a whole number. Remember that. If you put this answer into the system, it's going to mark you wrong later. So what should be the sample size? 82. Yes, you round up. Always, let me write this down. Round up. Even if this is 81.007, guys, you have to round it up to 82. So round up. So answer is 82 or more. And how to find ZC? Somebody asked me how to find ZC. I'm gonna write it down here. Inverse norm. Take 100% minus 99% and then divide by 2. Then comma 0, comma 1. You will get it. All right. Number 8. Michael, you had a question. What do you mean by 6 or 5? Eight. In a recent study of 48 graders, so N is 42. The mean number of hours per week that they watched television was 19.6. X bar. With a standard deviation of 5.8. S. Now, maybe some students are gonna tell me, why didn't you put sigma here? If he doesn't say population standard deviation, guys, you must put S. It's not sigma. It's not the population standard deviation. Find a 98% confidence interval. Okay. If S is given, guys, instead of sigma, you're going to have to run not a Z interval, a T interval. And let me show you how to run this thing. Everything is under stats, so let's put this here. So you go to stat, tests, and then 8. I know it's tempting, guys, to choose 7, but it's not a Z, it's a T, because he gave you S instead of sigma. So T interval, stats, X bar is 19.6, S is 5.8, N is, what was N? 42, and change the confidence level. It's 98. You can put 98 or 0.98. It will take it either way. Calculate. So I got 17.4 and 21.8. All right. Now let me show you guys how to write a statement here. If I'm asking you on the final, I want a conclusion. So you write with. You might not type this when you take the test, but you must select the proper, conclusion. With 98% confidence, you can say that the true mean number of hours eighth graders watch TV is between 17.4 hours and 21.8 hours. I bet, guys, it's a lot more now since everybody is staying home.
Professor?
Yes?
Hello?
Let's continue. Next question. 9. The grade point average for 10 randomly selected high school students are listed below. Assume that the grade point average are normally distributed. Find a 98% confidence interval for the true mean. Guys, when he gives you a data set, right away it's a T, not a Z. So you gotta use a T interval. So I'm gonna input those values right now. If you have your calculator, let's do it together. And we'll answer this question. Okay, let me clear L1. So I got 2, 3.2, 1.8, 2.9, 0.9, 4, 3.3, 2.9, 3.6, 0.8. All right, and look what you do. You just go to stat, tests, and then it's a T interval. Okay. Now, I have a data set, so you guys have to select data now because you have data. Where did I put it? I put it in L1. It shows L3 here, so I need to change that by pressing second and number 1. Frequency never changed this number. It's always 1. And he wants what, 98 or 95? 98, so we're good. And enter. So the mean is between 1.55 and 3.53. So on average, the average GPA of the class is between 1.55 and 3.53. What can you tell from this interval? Can you tell if the class is passing, guys, or you can't tell? Can someone answer this question? You know, 2 is a C, 3 is a B, and 4 is a A. What does this interval tell you? It says that the mean GPA of the class, on average, they have a GPA between 1.55 and 3.53. Well, actually, we cannot tell, because if the mean is close to 1.55, that means the students are not passing. It's below 2. But it could be bigger than 2. It could be close to 3.53. Then students are passing. The reason why you got, this very wide interval, because the sample is very small. If you have a larger sample, the interval will shrink. But small sample, it gave me a wide interval. All right. The numbers are right here, Muhammad. This is the T interval. You run a T interval and this. So T interval, and then it will give you those two numbers. This is the lower bound, and this is the upper bound. Number 9, that 9 we did. 10. A survey of 300 fatal accidents showed that 123 were alcohol related. Construct a 98% confidence interval for the proportion. So there's only one proportion function, guys, that you can use with one sample. It's this, one prop Z interval. It requires a 3 argument, X and N, and the confidence level. X is the number of successes, which is 123. N is 300, and the confidence level is 98. This is a very easy interval to come up with. So you go to stat, tests, and find the prop Z interval. Not Z test. The tests are when we do hypothesis testing. It's an interval, so it's right here. It's letter A. Okay, he wants X. X is a smaller number. N is 300. Confidence level is 98, and that's calculate, and that's the interval. And how do you write this interval? You write it like that. P is between, let me write it. So I'm reading it off the calculator, 0.3439 and 0.4761. That is the proportion, the percent of fatal accidents that were alcohol related is between 34.39% and 47.61%. If you are to write this in a statement, you say with 98% confidence, we can say that the true proportion of fatal accidents that were alcohol related is between 34% and 47.61%. Any questions here? All right. Number 11. This is the last question, guys, in chapter 6 for my on-campus class and chapter 9 for my section 98. A pollster wishes to estimate the proportion of the United States voter who favor capital punishment. How large a sample is needed in order to be 95% confident that the sample proportion will not differ from the true proportion by no more than 5%? So I got the confidence level, guys, which is 95%. And it says The true proportion does not differ from the sample proportion by no more than 5%. So that must be your margin of error. And I'm gonna write it as a decimal, 0.05. When it comes to proportion, the formula for n is this, guys. N p hat, q hat, zc over e squared. Again, this formula will be provided to you, so you don't need to memorize it. Okay, let me show you how we're gonna find the sample size. Okay. Confidence level is 95%. Z is 1.96. I ask you to try to memorize it, but if you don't, here's how you can find it. Just like I did earlier. It's inverse norm. Take 100% and subtract the 95%. And then divide by 2 because I have 2 tails. And put 0 and put 1. Well, guys, it's going to give you negative 1.96. You can trust me on that. So n will be p hat is a sample proportion and q hat is a sample proportion. If he doesn't give you both values, you use 0.5. And since he did it, we're going to use 0.5. Time is 0.5 times 1.96 divided by e. E is 0.05. And then we're going to square it. Okay, you want to compute this with me, please? So that will be, let me just do the math. I'll put the calculator here, guys, so you see what I'm doing. 0.5 times 0.5 times, open parentheses, 1.96 divided by 0.05, close parentheses, and square. There you go. And now, n. Okay, what should n be? What about if this was a multiple choice, guys? Which answer would you choose? There you go, one more time. It's 380, what? 85 and up, yes. You always have to round up, guys. Not round as we round normally, it's rounding up. Okay. Number 12. This is what your bulk of the exam, guys, is going to be from. It's hypothesis testing of 1 sample and 2 samples. I cannot emphasize enough how important this is. So we'll get into the good stuff now, including chapter on normal distribution. That's also very, very important. A fast food outlet claims that the mean wait time in line is less than 33.3 minutes. A random sample of 20 customers has a mean of 3.1 minutes, which is X bar, with a standard deviation of 0.8, which is S. He didn't say sigma, he didn't say population standard deviation. If alpha equals 0.05, test the fast food outlet's claim using p-value. Yeah, we're back to the recording. Thanks for noticing. So for number 12, let me just make sure I read it so it will show up in the recording. A fast food outlet claims that the mean waiting time in line is less than 3.3 minutes. So it is in the alternative hypothesis. A random sample of 20 customers has a mean of 3.1 with a standard deviation of 0.8 minutes. At alpha equal 5%, test the claim. So we're going to test that the mean is less than 3.3 minutes. As I said, guys, for my group of students, he can write it like that, and other group can write the null in the alternative the other way. Okay, it's a t-test. And how do we do the t-test? It's a stat, tests, t-test. You already know how to do that. You go to stats, and the 3.3. X bar, guys, is 3.1. S is 0.8, if I'm not mistaken. N is 20. And let me pause here and say something about this. A lot of students are not making sure that this is executed properly. You guys, you have to select the sign from the alternative hypothesis, which is less than. You have to select it and press enter. If you don't, it's not going to be selected for you. So this is less. Now it's gonna work. It's less than, and then hit calculate or draw. T, usually 3 decimal places, -1.118. And p-value, I'm sure you are tired of the p-value by now. You've been hearing about it half of the semester. Okay, this is bigger than alpha, guys. So you fail to reject HO. And if you fail to reject the null hypothesis and the claim happen to be in the alternative, you cannot support the claim. So you say there is not enough evidence at the 0.05 level of significance to support the claim. We're saying we cannot support the claim. So every time, guys, you do not reject the null hypothesis and your claim happen to be in the other hypothesis, you will not be able to support it. You only can support your claim if you end up rejecting HO. But in this case, we didn't. And that is number 12. Number 13. All right, so 13. A manufacturer claimed that the mean life of its fluorescent bulbs is 1,000 hours. A homeowner selects 40, so N is 40, and find the mean life to be 980 from the sample. So that's X bar, guys. With a standard deviation of 80, you should agree with me that this is S, not sigma. He's still talking about the sample. S equals 80. Test the claim. Okay. HO, HA. I'm gonna write it mean equals, actually, it says mean equals what? 1,000. So what would the alternative be not equal 1,000? All right, so.
Can you put the paper down?
And for students who take section 98 and 99, this is how you express it. Instead of A, you put 1. It's going to be the same thing.
Can you hear me, Professor Bazi?
What is it?
Can you hear me?
Yes, what is it, Muhammad?
Yeah, can you please scroll up? We cannot see anything.
What about now?
A little bit more.
You can see the screen right here.
Yeah, that's perfect. Thank you.
Yeah, no problem. All right, let's keep going. Yeah, let me know, guys. Have no problem because I don't see always what you guys see. So we need to test the claim. Where is the claim now? The claim is, for your information, let me show you where the claim is. The claim here is in the null hypothesis. It says is, which is equal. So I'm going to put it in the null hypothesis. Okay, t-test. T-test is very, very important test. Okay, let's do that together. Stat, tests, t-test, not data. I didn't give you raw data, so I give you a summary. 1,000. You have to assume that the null hypothesis is true until proven otherwise. Just like if you remember the court statement, the defendant is always assumed to be not guilty until proven otherwise as well. X bar is 980, S is 80, N is 40, and here, guys, you must select not equal to because that's the alternative sign. And then I can do calculate for you, and here you go. So T is -1.581. I'll write it down. And p-value is 0.1219. If you guys can't keep up with me writing, that's fine. I will scan the pages as well and send them in addition to the video. So I'll email them to you. This is greater than alpha. What was alpha in this question? 0.05. So what's the decision, guys? Fail to reject HO. And now the statement. I failed to reject HO and the claim happened to be in HO. It happened to be HO itself. So I would say there is not enough evidence to reject the claim. At the 0.05 level of significance to reject the claim. Don't guys decide to change the language. I cannot reject the claim means I accept it. If you don't reject something, it doesn't mean that you accept it. So please use the same, choose the same language that I'm using right here. Not enough evidence at the 5% level of significance to reject the claim, whatever the claim, that the lifetime of a fluorescent bulb is 1,000 hours. Any questions about number 13? Okay, let's go to 14. Let me project the question first. We'll read it and then we'll solve it. A recent study claimed that at least 15% of junior high students are overweight. In a sample of 160 students, 18 were found to be overweight. If alpha equals 5%, test the claim. So let's write it down first. At least, let's see how 15%. N is 160, X is 18, and alpha is 0.05. Okay. Let's write, how would you interpret at least, guys? What is at least? What symbol do I use for at least? I'm gonna put 4 symbols and you tell me which one is it gonna be. The first, second, third, or fourth?
4.
Oh, wow, we got so many mixed responses. You can't be in math. The beauty of math, it has to be only one answer. And it's not the second, it's not the third, and it's not the fourth. At least means it's this one. Or probably you're seeing it as the fourth from your side. Okay, at least means greater than or equal to. That is what at least is. That's at least. At most, guys, means less than or equal to. So at least will be like this. And since we are testing a proportion, you write it like that. And what is the opposite to greater than or equal to? HA has to have one of those signs. It has to have less than, greater than, or not equal to. It must be a less than 15%. Okay, this is how my students on campus write the null and the alternative. For students online, they have to write it like this. Less than 15% and equal 15%. And this is where the claim is. So anytime, guys, there is a statement that has an equal sign in it, the claim turns out to be in the null hypothesis. At least it means greater or equal. So there is an equal there. And we're gonna test this one right now. It's a proportion z-test. Okay, let me show you, walk you through the steps with this one. Stat Very easy once you figure out, you know, just what test to use. Tests, one prop Z test. Okay, value in the null hypothesis, 0.15. X is 18, guys. X is a smaller number always. N is 160. And now we have to choose the proper sign, which is less for the alternative. All right. Calculate. You see, Z turned out to be negative, which makes sense because I did a less than in the alternative. So Z is negative 1.3233, and p-value. Don't you love the p-value approach? It takes care of everything. All right. So the p-value is 0.0920. And we're testing at alpha 5%, so that's bigger than alpha. So fail to reject HO. And the conclusion. Fail, it's always there is not. Every time you use the word fail, you have to put not here. Enough. Evidence at the 5% or 0.05 level of significance to reject the claim. The claim happened to be in HO, and we failed to reject HO. That means we failed to reject the claim. We said there is not enough evidence at the 5% level of significance to reject the claim. So that's 14. I'm going to go to 15 right now. No, 15 is omitted. It has to do with the standard deviation. So we're going to go to 16 now. 16, guys. Okay. So now let me tell you which chapter we're working on. For my students on campus, we're working with chapter 8 now. And for students online, we're working with chapter 11. And a study was conducted to determine if the salaries of elementary school teachers from two neighboring districts were not equal. A sample of 15 teachers from each district was randomly selected. The mean from the first district was 28,900 with a standard deviation of 2,300. The mean from the second district was 30,300 with a standard deviation of 2,100. Test the claim that the salaries from both districts are not equal. So that's clear, guys. He tells us what to do here. HO, HA, discrete, I'm going to use mu1 and mu2, mu1 and mu2. He's asking us to check that they're not equal. So it's very simple. And this one will be always the opposite, which is equal. So this statement turns out to be the same for both sections. No need, you know, just to touch up or anything. The only difference is instead of A, you just put 1 here. Okay, this is a 2-sample, guys, t-test. It was a t-test in the previous chapter. Now it's a 2-sample t-test. The reason why, because he gave me the sample standard deviation of the first district and the second group in the second district. So you must use 2-sample t-test. He gives me N1 and N2, that's N1. He gives me the first mean, X1 bar. He gives me the first standard deviation, which is S1, X2 bar, S2. And let's run the test together, guys, and see how we execute this test. That's a very, very important question, extremely important. So I'm gonna get the calculator ready. Stat, tests, 2-sample t-test. It's number 4. Let's walk you through it. We have summary. So X1 bar. X1 bar is 28,900. X2 S1 is what? 2,300. N1, he says 15 in each. X2 bar, 30,300. S2, 2,100. N2 is 15. And you guys should agree with me that we should be not equal here because that's the sign in the alternative hypothesis. Just follow the sign in the alternative hypothesis. Okay, now pooled. If you are in section 98, 99, the author says by default it's no. But let me explain when do you put a yes. If he tells you that the population standard deviations are assumed to be equal, assume that sigma 1 square equals sigma 2 square, it's a yes. If he says they're not equal, it's a no. If he says nothing, it's a no by default. But here it says assume that sigma 1 square equals sigma 2 square, so pooled is going to be a yes. And calculate. I'm ready. And here's the answers. All you need, guys, the first two values, the T and the P. So T is negative 1.741. And P value, let me write it down to 4 decimal places, 0.0927. And alpha is 5%. So again, we're going to fail to reject. Okay, we failed to reject the null hypothesis. Let me answer a question for a student. I always forget about that. So, thanks. So T and P, the P value is more than alpha, guys. We failed to reject the null hypothesis. And if you fail to reject the null hypothesis and the claim happened to be in the alternative, you say you cannot support the claim, this language. Or you select this language if you will have 4 or 5 options on the test. There is not. You better look for the word not. Every time you have a fail, you have to look for the word not in the statement. Enough evidence at the 0.05 level of significance to support the claim. All right. One thing I want to do, guys, tell you about before we move to the next one, because it did concern me with some students. Let me show you what I'm talking about. And I would record it as well. If you get a p-value like this, I noticed that some students are ignoring the E. You cannot. The p-value is a probability, guys, and the probability cannot exceed 100%. So if you ignore the E, you're telling me that the probability is over 100%. That's impossible. Please pay attention to this. This means you have to move to 4 digits to the left. So actually your actual value is this, which is almost 0. So please keep this in mind when you work with the calculator. That's very, very important. Okay. No, we're not saying that this is the p-value, Muhammad, in the question. I'm just giving an example. If you come across this, so that means almost 0. And if it is almost 0, you always reject the null hypothesis. And just to remind you and how you can tell, there is that saying, it says if the p-value low, HO must go. So always with a low p-value, you reject the null hypothesis. Next question. $17. All right. You ready? This is, okay, for my students on campus, this is section 8.3. For my students online, this is section 11.2. And this is very, very important question, guys. 9 students took the set. Their scores are listed below. Later on, they took a test preparation course and retook the set. So it's the same students before and after. These are dependent samples. And the way you do the test, you don't use a 2-sample t-test because the 2-sample t-test is reserved for independent samples. Here, the samples are dependent. Testa claimed that the test preparation had no effect on their scores. So it didn't make any difference. Okay. Here is how you state the null and the alternative hypotheses for this. we do the mean of the difference. So we're gonna do the differences here. If you guys wanna help me, just do the differences. 720 minus 740, it's negative 20. So this is the difference right here. 860 minus 860 is 0. 850 minus 840 is 10. 880 minus 920 is negative 40. 860 minus 890 is negative 30. 710 minus 720 is negative 10. 850, that's a 10. 1200, the students got 1240, so it improved. 950 minus 970 is negative 20. Had no effect, guys, means there is no difference. We're testing here against 0. So when you do dependent samples, you test always against 0. If it says no difference, means whether it was a before score and after score, they're the same. That means their difference is 0. So we're testing here equal 0 and not equal to 0. Now, if he asks you, let me pause here and just show you another scenario. Continue. So, guys, when you have a question like this, this is a t-test and one sample, not 2 samples anymore, because I have the differences. So what I'm gonna do with you guys, I'm just gonna show you how to enter, those data into L1. So I'm gonna enter them. If you wanna enter them with me, that would be fine. Negative 20, 0, 10, negative 40, negative 30, negative 10. Make sure to use a proper negative sign. 10, negative 40, and then negative 20. All right. I go to stat, tests, t-test. So for this section, it's a t-test, guys. Data, I have data here. And it's always against 0. In this section, guys, you test against 0. I put my data in L1, I'm good, equal, not equal here, which is I'm good, and now we're ready to find the test statistic and the p-value. So T is, and the claim is right here. T is, guys, negative 2.4, and p-value is 0.043. And what does he want us to test against? What value of alpha? So less than alpha. And if it is less than alpha, what do you do, guys? Reject what? The null hypothesis. And what's the conclusion? There is enough evidence at the 5% level of significance to reject the claim. We're rejecting the claim that this test makes no difference, guys, because it did make a difference. Look here, guys, negative 20, this students improved, this students improved, that one improved, most of them improved. So we reject the claim that it did not make any difference. That means it probably did make a difference here. All right, so this is number 17. We're gonna go now to 18. 18, guys, it's section 8.4 with my group on campus, and it's 11.1 for my section 99 and 98. You already have it written here anyway on your handout that I sent you. Okay, let's do this one. We'll do it on a blank sheet of paper. In a recent survey of gun control laws, a random sample of 1,000 women showed that 62% were in favor of stricter gun control laws. In a random sample of 1,000 men, so we have women and we have men, 1,000, 62%, 60%. Test the claim that the percentage of men and women favoring stricter gun control laws is the same. So we want to test if the proportion are the same. Guys, when he says percent, it's the same thing as proportion. So it's a P1 and P2. P1 and P2 and the same, equal. That's the claim. Not equal. And I'm not going to write a statement for the online group because it turns out to be exactly the same, equal and not equal. Okay, this is a two-prop z-test. Okay, let's walk you through it together and let's see if we can do the test. We should. Stat, tests. Sorry, I should have gone. Okay, I'll go up. Two-prop, it's number 6. Okay. We need x1. Who can tell me what x1 is? X1 is an integer. It's a whole number. He didn't give it to us. So how would you find x1? Any ideas? Let me see. Okay, very good. Yes, that's correct. You take the 62%. If it doesn't give you a number here, guys, you take the 62% multiplied by 1,000. Exactly. 0.62 times 1,000. And then you put 1,000 here. And x2, guys, 60% and times 1,000. And then 1,000. Okay. But one thing I want to bring to your attention. Please, I'll change it. I'll change it back to 620. Let's suppose n was 957 and you do 62% times 957. Look what happens. I got a decimal. If you run the test with the decimal, the calculator is going to halt and tell you there is error. So if you get the decimal, guys, just round it. So put 593. Otherwise, you will not be able to proceed with the test. I'll go back to my value, which is 620. Okay, calculate. And I got Z and I got the p-value. Z is 0.92. And the p-value is 0.3592. Which is more than alpha. Fail to reject HO. And your conclusion, guys, is going to be, there is not, and I'll underline this, enough evidence at the 0.05 level of significance not to support the claim, to reject the claim, because the claim happened to be in HO, to reject the claim. Our claim in HO, and we said we cannot reject HO, that means we cannot reject the claim. It's as simple as that, guys. Number 19. Okay.
Can you hear me, Professor Bazi?
Well, what is it, Muhammad?
Sorry for interrupt, but the second one should be the p-value. I think you wrote Z twice.
Oh, yeah, you're right. Thank you, Muhammad.
You're welcome.
Good catch. You guys are paying attention. I like that. 19. All right. That's we did this concludes the review of two means and two proportion. Now we're going to a new chapter. For my on-campus class, it's chapter 9, and for my online class, it's chapter 4 now. All right. And the data below are the final exam scores of 10 randomly selected statistics students and the number of hours they study for the exam. Test the significance of the correlation coefficient using alpha equal alpha equals 0.05. In the claim, I would like you to change this one. I think that's a rho greater than 0. Okay, let's do it. I'm gonna pause here because it's gonna take me a minute to enter the numbers into L1 and L2. Okay, so let me use this question number 19, guys, to review this chapter actually. Okay, here's how you find. First question, I might ask you to find me R, correlation coefficient. Here's how you find R. So you go to Stat, Calc, number 4. Make sure you have the correct lists, L1, L2. Frequency list should be empty. And hit calculate, guys. So I got R equals 0.847. And let me write R squared because I'm gonna interpret this for you guys. 717. I'm gonna write the equation of the line as well. Y equals AX plus B. So I'm gonna write it here. 5.044x plus, we use a hat over the YB, 34.892. Okay, that's all I need for now. So if I give you this data set, guys, and ask you to find R, this is how you find R. Now, how do you interpret R? If R is close to 1, you say there appears to be a strong positive linear relationship between the number of hours studied and the scores on the test. So that's how you interpret R. This is the equation of the regression line, guys. Y equals 5.044x plus 34.892. I might give you a question to find just the equation, or I might give you a question to find Y if I give you X. Well, in order to do that, you have to come up with the equation. If I give you X to be 10 hours, you just plug in 10 here and then find Y. Now, how do you interpret R squared? Let me show you the interpretation of R squared. This is called coefficient of determination. Okay, here's how you write the explanation for R squared. You change it to a percent, 71.7% of the variation in the test scores can be explained by the variation in the number of hours studied. Number of hours studied using the regression line. So this is the interpretation for R squared, guys. Now the interpretation for R, I'll write it. There appears to be a strong positive, why positive? Because R is positive, linear relationship between X and Y. Don't put X and Y. Well, actually, he's not going to put X and Y in the answer. He's going to put the actual names, hours, and test scores. All right, so that takes care about 60% of the problem. And now the last part is to do the testing. So I'm going to show you how to test this one. Oh, Michael, if it's only showing A and B, stick around. I'll show you how to set the calculator, because you have to go to second number 0, scroll down to diagnostic, and make sure diagnostic on is turned on. So you press enter twice. Let me show you how to do that now. So probably that will benefit everybody. Okay, guys. If you don't see R, here's what you should do. And do it now as I do this. Press the second key and press number 0. You're gonna get this catalog. Scroll down until you see diagnostic on. Almost there. Here you go. I'm there. Press enter twice, and you're all set. Now, if you go back and do it, it's gonna show. Do it twice just to be sure. And now it should be there. Now, he wants us to test the claim that the correlation coefficient is positive. So here's how we test the claim. Rho, this is the population correlation coefficient. And for my students on campus, you put less than or equal to 0, but for students online, this is what you put. Greater than 0 and equal to 0. Here we say correlation is significant. And if you are in HO, correlation is not significant. So always we fight against HO. In real life, guys, when people want to support their claim, they'll try to make sure it turns out to be in H1 and not in the null hypothesis. Okay, let me show you correlation is significant. Let me show you how to do this in two ways, using a test on the calculator or using a table in your textbook. So I will show you how to do that.
Professor Bazzi, can you move your paper up so we can see you write the problem?
There you go.
Thank you.
Is that good?
Yes.
Okay. Is the voice still clear, guys?
Yes.
That's good. All right, here is the test. And actually this test that I'm gonna use now, you could use to find R, R squared, the equation of the line you can use for everything. Linear regression t-test. And watch, guys. It does magic here. Go to stat, tests, scroll up because it's at the bottom. And here it is, it's F. Linear regression t-test, enter. Okay. Are my values in L1 and L2? Yes, I put them in L1 and the Y in L2. Frequency is 1, guys. Do not change this one. You change it, you ruin the entire problem. And you can send me an email later. I'll tell you why if you change it, what would happen. Now we want to test rho to be positive, I said. So this is it. And done. That's all you do, guys. And then hit calculate and watch. You get T and you get the p-value. Let me write them down. P-value is 0.001. And look what else you get, guys. You get the equation, but written as A plus BX. You get A and B. You get what we call the standard error here, S, which is 6.3. And we get R squared and we get R. So everything is in there. You can use this linear regression t-test anytime. Okay, p-value is 0.01, guys. It's less than alpha. And if it is less than alpha, what's the decision? To reject HO. And if you reject HO, you say, there is enough evidence at the 0.05 level of significance. I don't know if it was 0.05, it doesn't matter. Whatever it is, it will work here. Significance to conclude that correlation is significant. So either if you reject HO, your correlation will be significant, this one will prevail. If you don't reject HO, you say we don't have enough evidence to conclude that correlation is significant. Now I'm going to show you another way, guys. You could have done this. If he asks you to do it with a critical value, just bear with me for a few seconds. Let me get the table. Okay. Another way to test the correlation, whether it is significant or not, using critical values and using this table. N is 10 and alpha is 0.05. So what is the critical value here? 0.632. What was R? What did we get for R? We got a number right here. R, guys, turned out to be 0.847. Here's what it says here. The correlation coefficient is significant when the value of R is greater than the value of in the table. Since my R is 0.847 and the value from the table is 0.632, so R is bigger than that one, then you can conclude that correlation is significant. So this is another way to do it. All right, let's continue with this. So I can do the goodness of fit and the independence test, and we'll wrap this up.
Professor,
Right. Yes.
do we have to do the critical value way, or it's an optional in the final exam?
I don't remember if I put it or not, but if I put it, I did provide you with a link to the table probably.
Oh, okay, thank you.
Yeah. All right, guys. So I went through 19, 20, 21, and all of them, just in number 19. So I'm gonna skip them and let you do them and just try to do the rest of those. Number 22, guys, this takes 2 seconds to do. Given the equation of a regression line, y equals negative 1.04x plus 50.3, determine whether there is positive linear correlation or negative linear correlation. What would you think, guys, here? It is positive or negative? That should be easy. Negative, I agree, because the slope is negative, because this is mx plus b. If the slope is negative, that means it's a negative correlation. The slope is positive, positive correlation. That's it. Okay, 23, goodness of fit test. I'm gonna do this one. A random sample of 160 car crashes are selected. And on the final, I think I'm giving you the option to use the p-value. So you don't have to worry about doing the tedious work by hand. A random sample of 160 car crashes are selected and categorized by age. The results are listed. The age distribution of drivers for the given categories is 18% for under 26, 39% for 26 to 45, 31% for age group 46 to 65, and 12% for group over 65. Test the claim that all ages have crash rates proportional to their driving rates. Okay, here's how we start. We start with stating HO and HA. Here, the distribution is as claimed, always. You don't change this language. So distribution of crash rates is as claimed. You don't have to write down what the claim is. It's this, all of this. HA, the distribution has what? It changed. Of crash rates by age is not as claimed. Now, where is the claim here, guys? He says, test the claim that all ages have crash rates proportional to their driving rates, which is given to us, so there must be in the null hypothesis. This is a goodness of fit test, guys. On the calculator, it's called chi-square GOF. This is the test. And let me show you how to run the test using technology. You gotta admire technology by the end of this semester because we used it quite a bit. Okay. In order to use the goodness of fit test, guys, you need to provide two values, the observed values and the expected values. The observed values will be given to you in a table or a box table or whatever. So they are given to you right here. So we have 4 categories and we have 4 observed values. We put them in L1. So I'm gonna clear L1, I'm gonna clear L2, and I clear L3 so students don't get confused with this. So you got 66, 39, 25, and 30. Now let me show you how to find the expected values. The expected values are the percents of the total. He must have given us 4% because I have 4 categories, and he did. The first percent, guys, was 18%, and you do 18% of 160. Not 18% of 66, it's 18% of the total, n times p. So 0.18 times 160. Then you do, for the next one is 39%. So you do 0.39 times 160. Then for the next one is 31%. So you do 0.31 times 160. And 12%, 0.12 times 160. Okay, I'm done. I'm ready now to do to show you how to do the test. Now you go to Stat, Tests, scroll up. It's this test, guys. Chi-square goodness of fit test. Enter. Confirm. Did you put the observe in L1? Yes. L2, but degrees of freedom. Degrees of freedom for the goodness of fit is number of categories minus 1. So I have 4 categories minus 1. It will give me 3. You must do this. Calculate. Okay. Let me write them down and we'll be done. Chi-square is 75.1. P-value is 0. Oh, look at the p-value, guys. It says 3.4474 e minus 16, which means it is what? What are you going to use for it? 0. Yeah, it's 0. All right, so which is less than alpha for sure. So we reject HO. And there is enough evidence to reject at the 0.05 level of, the 0.05 is very common, level of significance to reject the claim. So the crash rates, guys, by age have changed. They're not the same because we rejected HO. HO means no change, status quo. That's what HO means. When you reject it, that means you're saying there is a change. Things are not still the same. So that's 23. 24. All right. This is the independence test, guys. That's a chi-square test. A researcher is interested in determining if there is a relationship between exercise and blood pressure for adults over 50. A random sample of 236 adults over 50 is selected and results are given below. Test the claim that walking and blood pressure are independent. Okay, your HO, guys, it's the variables are independent always. So walking and blood pressure are independent. If you were to select this on the test, you just look for the word independent for HO. And for H1, walk-in and blood pressure are dependent. And he says, check if they are independent. So the claim is right here. All right. Okay, let me show you how to run this test. I got the observed values. This is all what I need. The calculator by itself will find the expected values. So please bear with me as I walk you through the process. It's a little bit of algebra you need to know here about matrices. So we need to be able to enter those in a table format, and there is something on the calculator we can use. It's called matrix. To access the matrix, guys, you do this. You press second, watch me, and you press X inverse. Then you go to edit right away and press enter. Okay, now we need to figure out how many rows and how many columns we have. I have 2 rows of data and 3 columns of data. So it's 2 by 3. So you just put 2 here and then 3 there and then enter. And start entering the values as you see them, guys. 35, 62, 25, 21, 65, 28. Okay, now I'm done here. Quit, go to stat, tests, scroll up, Enter. The calculator, you already told the calculator that I put the observed values in A. Look what the calculator is going to do for you. It's going to put the expected values in B. And then hit calculate. Okay, we're done. Chi-square is 3.473. And p-value, guys, there is no E here, so I'm not going to worry about it. 1761, which is more than alpha. Fail to reject HO. And you say there is not enough evidence at the 0.01 level of significance to reject the claim that walking and blood pressure are independent. Now, one thing, guys, you need to know, I might give you something like that and just ask you to find the expected values. I can ask the calculator to give me the expected values here. Watch, guys, look what you can do. Press second and X inverse again. You see your B, originally it was 3 by 3, now it changed to 2 by 3. So press on it twice. And one more time. Here you go, these are my expected values. You scroll right and left, you can see all of them. Okay. Last question, which has to do with section for my students online, section 13.1, and my students on campus, it's section 10.4. It's Anova. Where is that question? See? And we will be done, guys. Just give me 1 minute and we'll be done. Okay. The grade point average of students participating in sports at a local college are to be compared. The data are listed below. Test the claim that at least one group has a different mean. Okay. This is Anova, analysis of variance. Here's how you state the null and the alternative. And there are no other choices for what I'm gonna list here. Always you put here that the means are equal. If you have 4 of them, you put equal mu4. And here it's the same statement always. At least one of the means is different from the others. And that's actually the claim, guys, because he's asking us to check if one is different from the other. Which one, we don't know, but we can test if one is different from the others. Okay, it is Anova. And Anova is the last test, guys. So you go to stat, tests, Anova. You key in L1, second, and then number 1, comma, second and number 2, and then followed by a comma, second and number 3, and close. That's what you should have. Enter. And F, it's an F distribution. P-value is 0.2498. Okay, I don't need anything from the calculator anymore. And this is greater than alpha. He did do the solution using critical values. You don't have to worry about it. I'm just doing it with the p-value. So fail to reject HO. And if you fail to reject HO, you cannot support the claim. There is not enough evidence. Here, the computer solution is correct here. Not enough evidence at the 0.05 level of significance. Don't forget the level of significance, guys, to conclude or to support the claim that one mean is different from the others. At least is different from the others. All right, so let me just do this.